inheritance. All right, so now what we're going to do is go through some inheritance examples to continue with the PowerPoint kind of theory that I gave you this morning and give you a little bit more background in terms of being able to use inheritance in applications. So what we want now is make sure you get Programming Practice 3 and Programming Practice 4 loaded. So download these two files if you haven't done that already. And those two files, my desktop is getting slightly cluttered here, is going to give you code 3 and code 4. So when you unzip the folders, you get code 3, code 4. If you go into code 3, we see inheritance 1, 2, and we see protocols. Let's take a look at inheritance number 1 first. So go ahead and then double click. Now that we have our devices set up, we're going to run a Mac operating system. We're not going to run a, this is not an iOS, this is a Mac operating system example. But you can all play around with your devices now if you wanted to. Anyway, and after lunch we'll do a tic-tac. No, actually I think after lunch we'll do temperature conversion maybe and a clock. It's working! Oh, congratulations. So, you know, actually to tell you the truth, it's actually kind of exciting. After going through all that stuff, it's nice to actually see it work. So now don't ever get rid of your computer or your phone, because then you'll have to do it all over again. It's not that bad. It's just like I was trying to tell you, it's like 20 minutes to a half hour, or 40 minutes. Actually, it was more like 40 minutes for us to get everybody together to get them all done. Huh?
Can we do the whole, can we change the device to a different device?
Yep.
Is that going to be the same long process?
No, actually, you're already in the system. You just give me another device.
Okay.
I register to the new device. You upload another certificate, and then we create another provisioning for you on the other device.
Okay.
When you change, for the student accounts, you can only have, well, actually, no, I shouldn't say that. I think you probably could have more than one device. It used to be a one-to-one, where one device was registered for one computer on the student accounts.
Mm-hmm.
But I just noticed, actually, I have a couple of them set up to have multiple devices.
Okay.
So all we have to do is put your new device ID in there, and then you just have to, now that you know the process,
Mm-hmm.
your certificate's actually in there unless you change computers. And then you can register that device with that new certificate, and you just download the provisioning file and you load it up just the same way as you just did. So, and apparently, as I learned, Xcode, well, we're a little too fast for the Apple account, which is what the problem was, I think, because after a few minutes, everything just started working because everything was registered correctly. It takes a while for the account, so just keep that in mind if you do this at home. You set up your own account. Which you can do, just register for a developer account, pay $99, and then create an account for yourself, and upload your device ID, and upload your certificate, and download your provisioning file, and there you go. So what ends up happening is your online account will keep track through your certificate and your provisioning. We'll actually keep track of all of the apps that you've created and all of the devices that you're using. And then eventually you go through the process and you just add it to your developer account, and then you put it into the iTunes store. It's basically your interface to being able to deploy your applications. And so if you go through the source here in the organizer, you can see, you know, in fact I just opened up the organizer for my iPad that's connected here. I can see, in fact I've got a little thing here, but my yellow thing says a valid profile. So I'm good, even though I have a yellow, which is kind of weird. I have a yellow thing next to it, a warning, but I have a valid profile, which is kind of weird. I think it's because I don't have an app opened. I have a console application opened. So anyway, if this button here is green, don't worry about anything else. You're set to go. And in here I can see my provisioning profile, and it will last for 1 year, by the way. So your account, what we just gave you guys, will last for a year. And anyway, the devices has got a bunch of interesting stuff in it, and I have developer mode enabled. That's the other thing too. So if you don't have developer mode enabled on your computer, you usually get prompted to actually do that. So it's just a security thing. All right, so let's go back to inheritance. So we started to build the person and the employee yesterday. So you have a partially built project. This inheritance number 1 example is the completion of that. So rather than tediously going through and finishing it by hand, I'll show you the finished product that will make up for all the time we spent this morning working on the provisioning accounts. And then I'll put us back up to date. So person, in the one that I made, I had actually here, I'll make this look like the one that we just did. I had a string and a string name in there, I think, is what I did yesterday. So if you don't have a working person, don't worry about it, because you can use this. This is to go back to tell you what this is an inheritance 1. So the folder inheritance 1 in code 3, which is source code download 3. So I had name, if you remember, and we had age, and we manually did the set age and the set get name or get age. And then I won't do it for setting and getting, but we can do the same thing for actually maybe I should, but anyway, we can do the same thing for name if we wanted to. At this point, we can kind of see that the .h file and the .m file reviewed from last time allows us to, and this is actually using printf instead of nslog, which is actually kind of interesting. But we can synthesize here name, and in person I had that's what I did. I had property on the name. So let's do it this way. I had name in here. So what I'm doing is I'm showing you to review the concept both. So if I put integer age in here, I have to write my own setters and getters. This is reviewed from yesterday. Then I'm going to add the inheritance on. So if I do a property and a string name, instead of putting name up here, then in person, I synthesize name, then I get my setters and getters automatically. So I don't have to do this stuff. Now I could do the same thing with age. So just because this is an integer, that's not the difference. It's just two different approaches and two different techniques. So in here I'm synthesizing names, so I don't have to do a set name, get name. And then out into main, if I look at the main program, I'm creating a person here, object 1, and I'm initializing and allocating what we just did this morning. And then I'm going to set the age to 10 in here. I can also, put one in here to set the name. So I can go here and say that object 1 name, and then have the name equal to Bob or something. So let's see what's gone here. Visual interface person, name, well we don't have a name. I believe it's going to be capital. Well anyway, we can run the set name. We can run the set name. We can run, I keep forgetting I'm using set name, get name instead of name as a property. I can set the property, or I can use the function to set the name. And if I set the name, which I don't have actually over here, I have set age and integer age over here, but I have name, which means I have a set name and a get name. So I set the name, and then I can return the name just by saying name. So there's no get on the name, I just ask for the name. I can also use the name as a property, which is what this is actually. It's a property that's synthesized. So I have a set age and a get age. So back out here in main, I can run on object number 2 is going to, well, I'll talk about object number 2 in a few minutes, but here I've been kind of sloppy. I put the printfs in here. So if I run it, I see that I get the results down on the bottom. Age is 10, age is 15, grow results 150. So I ran a message grow, and grow sum from object 2. And object 2 is the employee that has a grow sum method inside of it. So from person, I'm extending NSObject, and then you can write employee as an example. Here's an employee. Import person.h, and then do a colon here, employee colon person. So you're inheriting from person now. Add an ID, but I can still set the age, set the name, work with that stuff. So I have another, a set ID that goes to an ID. We've seen this method, the way we add parameters earlier today. And then here's another method called growSum. growSum, if I look at the implementation of this, takes and returns the ID times 10. Excuse me, returns the age. So you get the age, times it by 10, and you growSum. So just to reiterate the point here, we also put it in an initializer. Initializer is essentially just creating a super object, which is a person. and then the person is going to create a super object, which is object, NS object. And then we can add to it. So we end up getting everything from earlier, and we just add to it in terms of what it is we're trying to accomplish. If I wanted to, I can run init from the earlier one inside of init and send back the name and the age if I wanted to overload those the initializers. Or I can make a method, a convenience constructor to do so. We'll see that a little bit later this afternoon, actually, with another example. In fact, I have 2 more inheritance examples that are going to show you some of that stuff. But starting out simple, we can just sort of see that I can run, although I only have set ID, and I have ID over here, in main I can create an employee and then run the same thing to set the name of the employee as an example here. I'll just do it right under here. So I have an employee, set age 15, because object number 2 is the employee. So I'll do here a 2 to set the name to Larry. So I got Bob and Larry as the 2 object names. And they're pretty much the same because employee is a person. So I can run employee methods, or person methods on employee. And then I can print out, get ID or get name. And so I don't actually set an ID in employee. In my employee object up here, I have a set ID and I have an ID. So in the employee here, I don't have it identified as anything. So if I printed out the ID, it's going to end up being 0 because I haven't assigned it a value yet. And it's an integer value. Here, if I set the ID, ID is going to be equal to this ID value. So, anyway, just food for thought in terms of inheritance. If we were to write the person employee to finish that example, this is what we would have written in there. At this point, I think some of you are actually up to speed with this, so you probably would have written it just fine. All right, so if I exit out of that one and look at inheritance number 2, I'm going to see a square and a rectangle. So I'm going to go open up inheritance number 2. And in inheritance number 2, we start out with this concept, this base concept of a square. Oops, excuse me, rectangle. Rectangle's first. Rectangle is coming from NS object. And rectangle is going to use 2 properties, a width and a height. And so we have a rectangle. So we have an initializer here. So we can initialize a rectangle with a width and with a height. And then we have a set width and a set height. Well, we just have a set width here, actually. It's going to override this one. So this one is an interesting example because we've overridden set width. Even though we got it from property and synthesize, we didn't have to put this in here. If we want to, if we add our own set width, it overrides the existing set width that we would have gotten with a property and a synthesize. So if you remember that other example, we didn't have a name, we didn't have a set name, but I ran a set name because the set name worked from property and synthesize. I'm going to have a set width whether or not I put one in here or not. If I want my own, I can create my own, which is what I've done, and it's going to override the one I'm going to get from property and synthesize. So people go, well, why would you want to do that? Well, if I had a ton of data and I only want to override one of them, the rest of it's all written for me, and whatever I want to reinvent, whatever I want to put in there, I can just go ahead and put in. So I don't have to override it, but I have the option to if I need to. So in the .m file, we see a synthesize with a rename. This is very old style, and you'll see this a lot. In the old days, we renamed it, and then we used the renamed one, but we also have the original one. Because people in the beginning, they felt, well, synthesize and property synthesize it, but how do we know what it is? So they did this equals thing. So we have this, because you didn't see this with person and employee, where it says synthesize with equals underscore with. You're like, well, why do that? You don't actually have to do that, but now in the synthesized version, if you refer to it with the underscore, this name works, also does that one. They both work, but in the old days, people wanted you to use this one because this is how the synthesized version of it was. That's gone away. You won't see that anymore. But you'll see this is an old code example, so I left it in there to kind of show you that. You don't have to rename it. So here in our implementation, we have the initializer with the width and with the height. Here, there's no check, but there is a check. We're going to self is equal to super in it. And then if self, we got self, then self, width and height, set the width and the height, and then return self. And then on our set width and height, our set width method, we're going self.width, self.height. Pretty basic. And then we have a print. Again, kind of using a printf. You can use an NSLog here too if you wanted to log it out. So printf and NSLog are doing the same thing basically. So, but this one is showing you this stuff. So if you look at the .h version of rectangle, you just see the property doesn't have that. It's just called integer width. So nowadays it's more common not to see this at all and just see this actually. And then also this is done on 2 different lines. So if you wanted to, you could put that on one by putting a comma in between. So you can go like this. If you wanted to, you can go and height and then get rid of this line completely. There's no rule that says it has to be on 2 separate lines either. Alright, so in the square comes from rectangle. And I actually like to put I like to put a space in there. But you can leave the space out, leave the space, it doesn't really matter. So it's coming from rectangle, and we're going to put an integer with size, square. So we have a new initializer for the square, for the rectangle that's coming from a square. So square's got an initializer and rectangle has an initializer. And then we have another method here called set size. And we don't actually have a size in here. We don't have a size variable, but we're still going to work with the height and the width that we had from the square. Because square, we're going to get a height and width with a rectangle. So if I look at the implementation for this, then I'm taking the set size, running set size is setting the height and the width to the side. So a square has got the same length sides, the height and the width are the same next to the square. So we've made a makeshift square out of a rectangle, you know, just keeping the height and width the same size, and we got a square out of that. So it's logically correct. So it's simple. It's kind of just basically an illustration to show you how you can pass the information back. So first thing people go is like, what do you mean self width? I'm a square. I'm coming from a rectangle. Rectangle has a height and width. So in C we super everything back. We go super. Take the width and set it in the rectangle instead of the square. So what I'm trying to do is show you that this is actually easier because we can run set size from the initializer. We're not supering back. In C++, we say if we want to override something from the constructor, because we have the automatic behavior in C++, we're overriding constructors, we're overloading constructors. If you're familiar with this, it's a big hassle. In this class, we're going to run this one from the subclass, from the superclass. And we send the parameters back to the superclass's constructors so that they can be initialized in that class. In Objective-C, we're saying, what, we don't have this automatic behavior. It's actually easier. We don't have to super back anything. We don't have to send it back because we are that object. So once we create that object, why can't we just populate the data right here? So that's what we're doing. Actually, in Java, you super back the information. You super back in Java and C++. That means you're sending the variables back to the objects that own the variables so that those variables can initialize the values for that particular data that belongs to those. But in Objective-C, we're saying, well, we're dynamic. We're the object. Don't we get everything? Aren't we everything anyway? So we're setting it right here. So we're a square, but we're setting a rectangle height and width right here. So super back. So a lot of people think, this is the one thing I think is easier in Objective-C than C++ or Java. We're not passing data back and forth. Why would we want to do that when we're the object? So there's no separation of the object. We're everything. I mean, we're a square and a rectangle. So why we can have an S for side and we can have a height and a width, and it all belongs to the same object, and we can just set it right here in our object. So it's less what I call supering back So anyway, size, we're going to return self.width when we get the size. And we're not reinventing the wheel, we're not using it, we're using rectangles, height and width, even though we're a square. We don't even have a side, we just have the concept of a side in our square. So if we look at the square here, we don't have any properties. We don't actually own any data. Rectangle owns all the data, but we have this concept of a side. And so when we do our initializer, we're going to return a square with an S value. The S value is going to be set in the size. The size of that S value is going to be set for the height and the width. So with set size, height and width to a size. So set it all in the current object is what I'm saying. And so when we run it, we can run it here. And here's the main. So I got a rectangle is going to be a new rectangle. And rectangle allocate a rectangle. And initialize it with a height and a width. And then a square, we're going to allocate a square, and we're going to initialize it with a size, 15, which is going to be our S. And then we can print it out. Rectangle print, square print, and let's take a look at print. So print is, let's see, no print in square. Square's got an initializer, a set size, and a size. But rectangle, the base class, has got a print. And the base class for the print prints out the height and the width, self height and width. So we're going to use the base class print, which is a member of square, which came from rectangle, and it's going to print out the height and the width. So when we go over here, oops, lost it. This print, oops, I was here. I'm going to go back to main, excuse me. So we can go here, square print or rectangle print. We're going to reuse it. If we create a new print, we can implement a new print. In fact, let's run it. We'll see. Oh, actually, let me change the wording a little bit here. So we got the rectangle. And in rectangle, I'm going to say rectangle print. And I got the width is going to be equal to something, and the height's going to be equal to something. So when I run it, it says a rectangle print, rectangle print, rectangle print, even though I'm a square and a rectangle. So then I can do this. Actually, this is an interesting experiment. Yeah, you can use NSLog instead of the print if you want. So now I'm inside of square. So rectangle, rectangle, square, square. I didn't have to mess around with virtual. I didn't have to do anything. I get automatic dynamic. So if I'm a rectangle, I know I'm both objects, but if I get referred to as a rectangle, I'm using the rectangles print. And if I'm referenced as a square, I'm using the square print. So you have really truly two print methods, two implementations. One overrides the other one with the reference count, because I can go back and use, so here's square after we have square print. I can go ahead and after I've done all the squares, I go and take that object, reference it as a rectangle. So if I do this, let me just do this, and I can get the rectangle one. So I can do ID. Let's do it this way. Let's go rectangle. Square comes from rectangle, so let's do square. Square another is equal to, and I'm going to put my little pointer in here. Let's do allocate a rectangle to a square. And we'll change the sides to 1 to 1, 1 by 1, because we're really making a square. And this is going to tell me I've initialized it, but I haven't used it. Yes, I know. So I'm going to do a square print. but I've allocated a reference of a square, and here I'll put it right here on the top actually. We'll go here, another print. So if I do another print, incompatible types initialize square with expression of type rectangle. It's okay. Should work. It's a warning. It's yellow, it's a warning. I get a rectangle print, but I'm a square, but I created a rectangle object. It's going to tell me I have incompatible type. What I should have done is this. I should have done this ID. And then I'm not committing to one or the other. Which is actually kind of interesting because down here now I have a receiver type ID is not ID, or interface pointer considered casting it to an ID. Well, this one might be interesting. I don't know if it can determine what it is. Yeah, it can. Rectangle print, because it was created with a rectangle. So even though it's ID, the type is reference type as an ID. I can change the ID to whatever kind of, ID is a generic object. So I'm not saying that it's a rectangle or a square. I'm just saying that I've allocated a rectangle. So if I did this with a square, because I created a square, I've got square print 1, 1 instead of a rectangle print 1, 1. And then you're going, well, how did I allocate a square with the initializer 1 and 1? And if I look at the square, when I created the square up here, I initialized it with a size 15. But I just made a square now using the rectangle initializer. But a square is a rectangle. So the initializers get inherited as well. So they're not constructors. In the Java land and C++ land, constructors are not methods. They're constructors, so they don't get inherited like that. When you create the object, you create that object with that constructor. You have to have a constructor that matches that object, or you overload the constructor and you stick the constructor in square. This constructor is not inside a square. It's inside a rectangle. But a rectangle is a square. A square is a rectangle. So I can go back through the hierarchy and run a previous constructor to construct it, which is what I've done here. Just letting you know, more flexibility, you have more control over it. Initializers are not constructors. They're separate methods that you're creating. You're kind of inputting the initializer concept in there, but you don't have all those rules you have to follow with overloading constructors and calling constructors and having this object allocate this data and that object allocating that object. In Objective-C, it's all the same object. Allocate it any way you want. You have more flexibility, more control over it. No automatic behaviors happening with you with all that constructor stuff. So some people like that, some people don't like that. If you grew up with constructors, you're wondering, what are the constructors? Nah, you just do it all yourself. More flexibility. So no constructor rules, no overloading, no something like that. So in a lot of ways, that's a little bit easier. I'll leave you with that one on inheritance number 2. And protocols. Let's wait for protocols until after lunch. It's 12:16. So let me stop this video because that video is basically going over. And you see, inheritance, there's really nothing to inheritance. Inheritance in Objective-C is fairly simple. Inheritance in C++ and Java, a lot more complicated. And there's so many more rules. We still have a single line, so we're very Java-like. But we're going to see after lunch, we have this interface concept. We have protocols and categories, which I'm going to show you after lunch, which are similar to interfaces. A protocol, which is this next example I'm going to save till after lunch here, is a set of rules. Protocol is a rule. So when we look at the protocol, it's like an interface, which is a bunch of rules, but it's also a tagging system. But they're used for slightly different purposes, the categories and the protocols. And we're looking at creating class methods and member instance methods and using them for different purposes, and then including protocols into the project to give our class some generic behavior that would be used sort of like an interface. So we'll hit that after lunch because it's a good stopping point right now. So how long do you guys want for lunch?